All right, we should be live. And welcome to another episode of Hoot. Today we will be talking about GitOps, and with me Stefan from Weaveworks, who will do a demo for Flagger. And we do these Hoot episodes once every 2 weeks on 1 p.m. on Tuesdays. So feel free to join, subscribe to get notified of the next episode. So today we're going to do a short intro to GitOps, and as always, a hands-on demo. Stefan will do the demo. And of course, we'll be, as always, monitoring the chat. So if you have any questions, feel free to just ask it, and we'll answer it live. So, Stefan, you want to introduce yourself briefly?
Sure. Hi, I'm Stefan Prodan. I work for Weaveworks. I'm doing open source development. I'm working on our continuous delivery tools like Flux, what I'm going to show today, and Flagger, which is a progressive delivery tool. And I'm very excited to be here.
All right. So we'll start with a short presentation. Let me share my screen. Here we go. And we'll talk a little bit about GitOps in general. So what is GitOps, right? And the idea with GitOps is that we can, because modern infrastructure is what's called declarative, essentially we can represent its state in a declarative form, essentially YAML. We can represent its state in source control. And GitOps is kind of the next step after configuration as code. So you have your configuration in source control already. Instead of taking it from there and applying it to the cluster the other way around, the cluster will watch Git and will apply the configuration itself as it changes in Git. So essentially using Git to do the operations, right? So making a change in your Git repo will automatically do the operations required to essentially deploy those changes to your cluster. So that's kind of in a nutshell what is GitOps as far as definition, right? Operations via Git. And let me next slide. Why would we want to do that, right? So it gives us all the advantages we know and love from source control into Git. So we can have an audit log and see exactly what happened in our cluster. We can revert to a previous state. We can review changes in pull requests. And we can even use pull requests and test those changes in kind of like in a CI flow, right? So all the stuff that we like and love from source control development, we can now apply to our infrastructure. So that's kind of the motivation of why we want to do GitOps. And talking briefly about how are we going to do that, and again, this is all in a nutshell. We're going to see a demo explaining how it's done in real very, very soon. So anything that can take your state of Git when it modified and applied to a cluster can be considered as GitOps, right? So you can homemade stuff with your CI/CD pipelines, add some Git webhooks, essentially get some sort of a bot to watch your cluster, and whenever it's modified, deploy those changes into your cluster, right? If you don't want to do all that work yourself, there are off-the-shelf tools to do that for you. And one of these tools, Flux, is something we're going to drill down a bit more today in the demo, but Flux is a purpose-built tool to help you do GitOps with Kubernetes and your Git repo. So as far as GitOps, there's also, of course, challenges. We did say that you get all the benefits of source control, but declarative configuration, it just means you're going to be seeing a lot of YAMLs. And I think that's something that will be solved as the industry develops. But yeah, essentially, code is more concise because it's imperative, right? You can have functions, you can have loops, versus declarative is more verbose due to its declarative nature, right? You have to declare everything that's happening. So a cluster state that's managed in Git will have all these YAMLs that represent the state. You'll be seeing a lot of YAMLs, right? Another thing is that you want to take into account is secret management. You probably don't want to have secret data in Git, and there are several solutions for that. There's external secrets from GoDaddy that allows you to use your KMS to decrypt secrets. There's seal secrets from Bitnami that allows you to use PGP to decrypt secrets. Flux, in addition, has support to Mozilla Secure Ops, which allows you to encrypt arbitrary YAMLs, not just secrets, which is nice. Whatever path you choose, just take that into account, you know. One of the classic ways to get a Bitcoin miner in your cluster is if you have a secret on Git in a public repo. There's bots scanning for this stuff all the time, so just be aware of that. Now, another thing that to take into account is that the cluster state may have drift from the state declared in Git, and sometimes that drift is actually desirable. So for example, if you have a pod autoscaler that scales your deployments, you want to make sure that your GitOps solution will not scale them back, because the replica number in Git is 1, while the autoscaler tries to get them to 10, right? So you want to pay attention to these details, and there are solutions. We can talk about it later. So as far as another thing to take into account as far as intentional drifts from the cluster state is automated rollbacks, right? If you try to deploy something and it doesn't work, it failed, rollbacks, you want to make sure that your solution doesn't kind of force and reapplies it, that it's kind of aware of that something has failed and it should kind of wait. All right, with that, we can talk. I'll hand it off to Stefan to do a demo. If there are any questions, I'll be monitoring the chat, so feel free to ask. Let me stop my sharing. Here we go.
Sure, I have a couple of things of what you said. The idea of GitOps is not only that you apply what's in your Git repo on the cluster when you do a modification, is continuously apply that state.
Yes.
If you, for example, say you do your homemade deployment with a CI tool, right? So any CI out there is capable of reacting to a Git commit, and you can have kubectl in there and apply the whole thing every time on the cluster, right? The problem that GitOps resolve is correcting drift. Let's say someone with access to the cluster makes a manual modification. Unless you change something in your Git repo, your CI tool will never override that change. If you use a GitOps tool, a specialized GitOps tool like Flux and others, then if someone makes a change in the cluster, let's say it changes the HPA or changes the limit or changes something that's declared in Git, Flux will detect that change and will revert it, something that you cannot do from CI. Another issue with driving all of that from CI is the fact that every time you add a cluster to your fleet, or you, let's say, you have a staging environment, you have a production environment, then you say, hey, I want a pre-production environment for various reasons or whatever. When you add that cluster, then you have to modify all your CI pipelines, and you have to add that kubeconfig to your CI, open up your Kubernetes API so the CI agent can see your cluster. The advantage of GitOps is that instead of connecting to the cluster from outside, it runs inside the cluster. So you can spin up a cluster, let's say in a private network, no one has access from internet to the Kubernetes API, and you can still synchronize with public repositories. You can reach out to GitHub from inside your cluster, pull the changes inside, reconcile them without exposing your Kube API. So GitOps has a lot of advantages in terms of history and stuff like that, but it also brings up a new security model where the cluster is reconciling its state, is not something from outside that connects to it as cluster admin and changes that state. So from a security perspective, is something that a lot of companies love about GitOps, and that's why I think in the last couple of years has been more and more popular as a solution.
Yeah, that makes a lot of sense. And that kind of shows the difference between the, a lot of time you're in a startup, you just want to do something, you think, oh, I don't want to learn this tool, Flux, look at the guide, it's so long, I'll just do it in my CI myself. And essentially this tool also encompasses all those lessons learned that over the years. So I personally think, there's a purpose-built tool for that. It's probably worth at least understanding why it's there. So yeah.
Yeah, I can. So we have developed Flux initially 4 years ago when Kubernetes was young, Weaveworks was very young. And why we did it was because we had and we still have a very small team of SRE people, right? So debugging CI jobs and everything like that, it's takes a lot of time. So we basically made Flux to serve our own purposes. We said, okay, like we do with code, we want to push something to Git, and the cluster itself should take it from there. If it fails, it should let us know. But I don't want to build CI pipelines every time I'm changing something or I'm adding a cluster. And that's how it all started. Then there was this other need, like, okay, in your CI pipeline, what you basically do is you build a container image and you push that image to the registry. Okay, now on your cluster, there is the old container image running. In order to change that, you have to go, let's say, in your Kubernetes deployment spec. Back then, Kubernetes deployments didn't exist. It was a
replication controller.
Replication controller, yeah. Right. So you have to go into a replication controller in the image tag, and you have to change manually that the tag. Like, okay, now it's not running this commit. I move to the different one. And in order to automate that, because we didn't want to make manual changes every time to YAMLs while we are building new images, we made Flux aware of container registries. So what Flux does, it scans container registries, it finds that, okay, someone pushed a new image, and it knows how to patch that particular YAML and write it back to Git. So it scans the image, detects a new image, writes it in the YAML, commits the YAML and pushes the YAML back to Git. Then the other side of Flux will say, hey, there is a change in the Git repo that I made, and I will apply it, right? So Flux version 1 does a bunch of stuff. And later on, Helm got very popular. 3 years ago or something like that, Helm was the solution to, trim down the YAMLs that you wrote. So we've created a Helm operator, which is a thing that should let you define Helm releases like you would define Kubernetes deployment. You can have a Helm release YAML, you place it in your Git repo, that gets applied on the cluster by Flux, and then there is this operator, Helm operator, which says, hey, I have to install or upgrade this particular Helm release, and it acts on that. And we've developed Helm operator. Then people said, hey, I want to get charts from Git repos, not only Helm repos. Great. So we had to duplicate the things that Flux was doing into Helm operator. Helm operator had to do Git operations, had to connect to Git, authenticate to Git, pull Git repos inside the cluster and apply charts from there, install them or upgrade them in Helm terms. So over time, we've seen that both projects are growing. They have a shared code base, but it's really hard to maintain the two. And both of them have evolved into two monoliths, basically. So what we did with Flux version 2, and that's why Flux version 2 is a different project from Flux. It has its own Git repo. It's called Flux 2, and we also have Flux and so on. We did the same as Linkerd did with Linkerd and Linkerd 2. The idea was to break apart these controllers and create dedicated, let's say, microservices that will that will be dedicated for specific things. For example, now in Flux version 2, we have a controller called source controller. And the source controller, what it does, it knows how to connect to Git repos, how to pull changes from there, how to monitor Git tags, commits, and branches. Also, source controller knows how to connect to Helm repositories and how to fetch Helm charts from there. And we also added recently support for S3 buckets. So GitOps in Flux 2 is no longer only about Git. As long as you have some kind of storage, for example, Minio is a great S3 solution that you can run on any Kubernetes cluster. You can push all your YAMLs in there, and you can say, hey, I want to reconcile my, my cluster state with this particular bucket, right? So in Flux version 2, creating this dedicated source controller, we could easily expand Flux to other things than just Git. So once we made this source controller component that can pull things inside the cluster, that means Flux is no longer limited to a single Git repo. That was one of the Flux version 1 main limitation. Flux version 1 will only synchronize with a single Git repo. If you want to add a second Git repo, maybe with other things that also need to end up on your cluster, you have to install a second Flux.
Yeah.
It also was a problem with multi-tenancy. If you have multiple tenants, let's say multiple teams inside your organization, let's say a tenant equals a team. You don't want a team to be able to modify namespaces or objects that are created by a different team. So how you can do that with Flux version 1 is you install a Flux per team, and then you set up Kubernetes RBAC, and you restrict that particular Flux instance to the namespaces that team owns. But then what happens if you have 100 teams and all share the cluster? You'll have to install 100 Fluxes and so on, right? So these were the main drives of developing Flux version 2. We want to add multiple sources, no matter from where, register them inside the cluster, and we want to ensure that we can do multi-tenancy without you having to install all the things per tenant. So how we solve that in Flux version 2, we have source controller, which pulls sources. Then we have specialized reconcilers. One is called a customized controller that can apply plain YAMLs from a source, or it can apply customized overlays. And the other one is called Helm controller, which is the next version of Helm operator and so on, that can install, upgrade, test, rollback, and uninstall Helm charts, right? And Helm controller and customized controller, they both share the same sources. So if let's say you have a Git repo that has charts and also has plain YAMLs, you register that Git repo once, and then to customized controller, you say, hey, please apply this directory. And to Helm controller, you can say, hey, please apply these charts from the same repo. That means we only pull the repo once. When something changes in the repo, we notify customized controller and Helm controller, hey, there is a new change through a Kubernetes event. and those reconcilers will act immediately. In Flux version 1, you had to wait like 5 minutes or 7 minutes or stuff like that every time something changes. And that's yet another problem. Like if you have a staging cluster, maybe every time you do a git push, you want that change to be reconciled immediately on your cluster. You don't want to wait 5 minutes, 7 minutes, whatever. So in order to solve that issue, we created yet another controller called notification controller, which is something that you can which you can declare webhook receivers. And you can say, hey, create a receiver for me, expose it through the ingress or a load balancer, and listen to events from this particular Git repo. When something changes there, let the system know, let Flux know that there is a change and it needs to pull it instantly in the cluster and apply it. So you can have this immediate effect if you set up webhooks. Also, this notification controller deals with incoming events, but it can also dispatch events. For example, let's say you add something to your Git repo deployment, and that deployment, after it gets applied on the cluster, it fails, it crashes, it enters a crash loop. Maybe the image URL is wrong. With Flux version 1, you had no idea that happened because Flux version 1 only look at, hey, is the YAML valid? Yes, okay, apply it. And that's it. In version 2, what we did, we allow people to specify health checks. So when you apply a Git repo, you can tell Flux, hey, after you apply, make sure all these deployments are healthy. The new version is actually rolled out inside your cluster. If it's not, issue an event and tell me what is the error inside Kubernetes. And notification controller can dispatch these kind of events to Slack, Microsoft Teams, Rocket Chat, even your custom webhooks and so on. So we also improved here a lot in terms of observability. We issue events, Kubernetes events for everything that's happening. We can dispatch them to other notification systems. And we also expose Prometheus metrics. So you can, I'll try to show you a dashboard. The idea is you can, if you don't want to look at a Slack channel, you can also create with Prometheus and Prometheus Alert Manager other definitions. So you can have like in, I don't know, PagerDuty or whatever you are using to in your SRE team, you can get a ping, hey, that deployment failed. It got applied and then it failed, right? So that were, let's say, the main drives for going from Flux version 1 to Flux version 2, which is a total rewrite. There is no shared code between the two. Flux version 2 is written using the controller runtime libraries from Kubernetes, and we use KubeBuilder, which is a tool to scaffold Kubernetes controllers very easily. And we use these tools, these modern tools, to build version 2. Okay, I think I've talked too much. Let's
that's great.
show how it works.
It sounds like a lot of it was driven by enterprise adoption, which is great to hear. Yeah. So
yeah, I mean, the part with health checks, for example, is not only enterprise, it's more about the small startups that they don't want to set up yet another monitoring system, because you can, of course, can do that. I mean, there are, I don't know, New Relic, Datadog, you name it. There's a bunch of services that allow you to deploy something on Kubernetes, and it will monitor everything for you, and it will do all that stuff. But from a continuous delivery perspective, many people expect that the tool that rolls out the new version, that tool should also deal with health checking and alerting, right? In Flux version 2, we're not going to deal with that. There are so many solutions, but yet again, our users come back to us and said, hey, we would like some alerts here because I don't want to pay yet another thing to do that for me. And yeah, Flux is open source, it's free, so you get all of these things for free.
Makes a lot of sense. And I also really like that modular approach because, today it's Helm and customized. Tomorrow, someone will come up with a new tool. And it sounds like with this architecture, it'll be very easy to edit and add support to a new way to generate those YAMLs. I We have some customers, they provide their own abstraction layer to their teams because Kubernetes YAMLs are Kubernetes YAMLs. So I see it as kind of a way to enable these custom use cases. So it does make a lot of sense in my head, kind of future-proofing Flux in a sense.
Yeah, I mean, Flux is powered by a project we call the GitOps Toolkit, which is the GitOps Toolkit is made out of Golang packages and APIs and CRTs. So, and Flux version 2 is built with the GitOps Toolkit components. So if you want to add something new to Flux, the way you do it is you will create a new API or write a controller for it. And then using the current libraries that, can listen to source changes, can issue events and so on by using those already made libraries, it's way easier to extend Flux than what it was back then with Flux version 1 or, I don't know, Argo CD, Jenkins, all these things, right? You have to contribute those changes to upstream.
Yeah.
And it's very hard to do that because you want to change something and maybe you break some other component, being all these solutions like monolith, right? What we are trying to do with Flux version 2 and the GitOps Toolkit is instead of you modifying Flux itself, you'll deploy your own controller, and that controller will be part of the whole thing, so you can easily extend the pipeline with new stuff without having to merge them upstream or stuff like that. Okay, I'm going to share my screen and try the demo.
All right.
Okay. Let's make this bigger. So this is the repo, Flux 2. Start it if you can. We have like a star FOMO because, yeah, we started from zero. Okay, I'm going to use a repository I've made in the Flux CD organization. And this repository is an example of how you can structure your Git repo so you can deploy Helm releases and plain YAMLs to more than one cluster. The idea is no matter where you are working, what organization you are part of, you definitely have at least two environments. Let's say a staging one and a production one, right? Many organizations out there have way more clusters. I don't know, a pre-production, a production cluster per region, and so on, right? So the idea is with Flux version 2, you can create a repository and from there manage not only a cluster, but your whole fleet of clusters. So I'm going to use this repo to set up a cluster that I have. The first thing I'm going to do here, I'm going to fork this repo on my personal GitHub account.
Before you do that, let me read some questions from the chat.
Sure.
When will Flux v2 or GitOps Toolkit generally available for use?
Okay, let me answer that by looking at the roadmap. So we published the roadmap here, and we've created 3 milestones out of Flux version 1. One is future parity with Flux in read-only mode. What read-only mode means is where you run Flux on your cluster without Flux writing back to Git container images updates, right? And version 1 in read-only mode is 100% at future parity with version 2. So if you are using Flux in read-only mode, you can migrate to Flux version 2 today. If you are using Helm operator version 1, that's also at 100%, you can switch to Flux version 2. If you are relying on the image update feature that's currently in development, we have finalized the API design, and now we are working on things like authentication to container registries, ECR, GCR, ACR. Every single cloud out there has a different type of authentication. It's very hard to deal with it, and we are still working on this. But I encourage users to give the current image update controls a test and see how they work. We also created, so let me go back here. So for version 2, we are using GitHub discussions for API proposals, announcements, and everything else. I especially love GitHub discussions because once you publish all this information on Slack, the other day is lost. Like GitHub discussion is a place where you can have a conversation. Is there, is index, you can go back to it and so on. And we published migration guides for Flux V1 users in read-only mode, Flux V1 users that are using customize, and users that are using Helm operator. And we are...
It also answers, there was another question, ETL migration guide for Flux 1 to 2. So they're already out.
Yeah.
Perfect.
We have a migration guide from V1 to V2, and we also have very detailed Helm migration guide written by Hide, because we changed the API on how you define a Helm release, and we've documented here how you have to modify your YAMLs to move from Helm release version 1 to Helm release version 2. And yeah, please give this a try, and let us know if I don't know, something doesn't work for you.
And how should people let you know, by the way, in the discussions?
In the discussions, directly here on the migration topic, of course, Slack and so on, but we prefer to have discussions on GitHub. I think it's a great way to offer feedback and have some history of what's going on.
Makes sense. And there's another question about multi-cluster, but I think you're going to touch that in the demo. So I'll just let you do that. And if it's still unclear, ask it again, please, Ramesh. One more question that I see here is that you mentioned that Flux monitor the container registry and does the deployments based on the new image released and pushed. But if someone wants to roll back to an old image, how can they perform that?
So Flux will not do rollbacks to old images. And the reason why, for example, version 1 doesn't do it is very simple. Let's say you connect to ECR and you ask ECR, hey, give me all the tags. And for some reason, you get rate limited. And ECR will give you only half of all the images. So you'll say, hey, my latest image is an image from 3 months ago. Okay, let's upgrade to that. And it will roll back 3 months ago and everything will crash. So what we did in Flux, we built some gatekeepers there. So it will never do the rollback automatically. It will only go forward. So if you want to roll back to another image, you should retag that image and push it with a new tag, and only then it will move forward. This is more of a limitation of container registries as a service, where you cannot reliably cannot reliably think that what you get there is the latest version, right? So that's why Flux doesn't do rollbacks on its own.
I could see the pain when you answer that that you felt the production outage.
Yeah, many people asked us like, well, I've deleted an image and it didn't roll back. Well, it doesn't. So if you want to do rollbacks, use Flagger, because it will also test your app and it will do the rollback consciously based on metrics and so on, right?
All right, with that, let's continue.
Okay, so I had forked this example repo, and what I'm going to do, I have here an empty cluster. Can you see that?
I can see it, but it might be too small on an average screen.
Okay, so I have this GKE cluster, nothing on it. What I want to do is install Flux on this cluster and tell Flux to synchronize with the Git repo. So we've created a CLI called Flux, which you can install with Brew, and or you can download the binary. It works on Linux, Mac OS, Windows. And you can tell Flux to the CLI to create a repository for you if one doesn't exist. And we have support for GitHub and GitLab, and we are extending support to other platforms like Bitbucket and so on. We are also working on a Bootstrap Terraform provider. We have an alpha release. The idea is that you run a single command that creates the repo for you, sets up the deploy key.
People are asking to increase the font size.
Okay. Better? I guess it's better. Oh. Okay. So what these commands expect is your GitHub username. Here it can be your own personal username, or it can be your organization name. If you are creating the repo on your personal account, then you have to tell Flux, hey, this is a personal account. When you are using a GitHub organization, you can also tell Flux to give access to specific GitHub teams to that repo, so they will have right access to it. You tell it the repo name, and you tell it what's the name of your current cluster. And let's suppose my cluster is the production one, and I'm going to tell Flux, hey, bootstrap this cluster from this repository. I'm going to run this. And
what's happening? Someone's asking if there's a workaround for Bitbucket right now.
yes. So what is happening now, Flux, the CLI, has pulled all the manifests from GitHub, the latest GitOps Toolkit manifests. It installs all the custom resources that you'll be using to control Flux. And it also installs the Flux components, which is source controller, customized controller, Helm controller, notification controller. You can pick and choose. I mean, if you don't need notifications, you can install Flux with only 3 controllers. Or if you don't deal with Helm, you can only install source controller and customized controller and so on. So these controllers are optional.
But so someone asked about Bitbucket. If they want to use the Bitbucket today, is there something they can do to use Flux and Bitbucket today?
Yes. If we go at the doc side, in the installation guide here, there are instructions for generic Git servers, where this works on any kind of Git server that supports authentication, be it an SSH deploy key or be it a token. You can also use HTTPS only authentication with a token generated by your Git provider. So we already have users that are running Flux version 2 on Bitbucket and on Gitea and other platforms. It's no longer just run a single command. You have to run a bunch of them to create the whole thing. But in the end, you'll have the same result. Okay, so let's see what happened on my cluster. So with the Flux CLI, I can ask the Flux CLI to check my cluster, and The check command, what it does, it verifies that the Kubernetes API and your kubectl installed on your local machine are on the right versions. We only support Kubernetes 1.16 and 4. That's because of CRD changes in 1.16. And Flux check will tell us which components are we running and at what version. Now, I can list the sources that are registered on my cluster. So I can do Flux get sources git. And here I'm seeing that, okay, I have a Git source called Flux system that was cloned inside my cluster from this branch. And this is the current commit that I'm using.
So a source could be that Git repo or a bucket or a Helm
or a Helm repository, yeah. And now if I'm going to look in my repo that I've cloned, I'm going to see that there is the new commit called add manifests. Let's look at the commits a little. So the first commit was Flux has generated all the GitOps Toolkit components. It bundles them in a huge YAML with all the custom resource definition, namespaces, deployments, everything, commits that to your Git repo, then applies that on the cluster. So Flux starts on the cluster. Then it creates a second commit with 2 objects. And let's look at this. So first we have a Git repository definition. So this is the custom resource on how you can register Git repositories inside the cluster. And how this YAML looks like, you have your URL, which is prefixed with SSH. There is a deploy key secret that the Flux CLI created for me. And it also has configured the deploy key in GitHub. And then I'm saying here, hey, I want to synchronize with the main branch every minute. So this part, what it does, it pulls the Git repo inside the cluster. It doesn't apply anything. Source controller, so source controller is the thing that reacts to Git repositories. What it does, it connects to the Git and it pulls the changes inside the cluster. Then we have a different definition, type customization, where I'm saying, hey, from this source, from this Git repository called Flux system, apply everything that's in cluster production in that directory, right? So with one piece of configuration, I'm telling Flux, connect to this Git repo and pull the changes inside. And with the second configuration, I'm telling Flux, hey, from that particular repo, apply only this path. So now if we, let's say, go back to the repo and we look at in clusters production, we see here this directory, Flux system, which was generated by the CLI and committed to Git on my behalf. And here I've defined 2 things. One is my infrastructure items, and the other one are all my applications. And this is how you could, for example, structure your clusters into layers. No matter what you do on Kubernetes, you'll have some infrastructure things. For example, you'll have an ingress controller, or you'll have, I don't know, some CSI plugin or something like that, right? And in the infrastructure definition, I'm saying, hey, apply this directory called infrastructure, which is at the root of my Git repo. And if we look in here in infrastructure, I've added a couple of things. Nginx, the ingress controller, a Redis cluster, and some sources. And let's look at these sources. These are different type of sources than Git. I've defined here a Bitnami source. And if we look in here, what I've configured, I'm saying, hey, I'm defining a source of type Helm repository. This time is not a Git repo, and has this URL. what source controller does, it connects to every 30 minutes. This time it connects to Bitnami and pulls the Helm repository index file, which has all the charts that Bitnami is publishing on the repo. And I'm also registered a second Helm repository, which this one is my own Helm repo. It's hosted on GitHub Pages. And I'm also saying, hey, pull also this Helm repository for my app. Now, if I'm going in here and I'm saying Flux get sources Helm, it will tell me that, okay, these two sources are registered, and this is the latest version of the index that was pulled from those sources. Now, I want to install Helm charts inside my cluster from these Helm repositories. How can I do that? There is another custom resource called Helm release. So let's make this a little bit slower. Okay. So I have here my apps directory. Inside here, I have a base directory for my application, and I have a release definition. And here it is. It's a type Helm release. The source is from this repository. And here are my values. So I can override the values for that particular Helm chart with my own things. And because this is in base, these values are common for both staging and production for all my clusters, right? And I'm configuring podinfo. Hey, here is my Redis class, my Redis instance, and please enable ingress for me. Here, I'm not setting the ingress DNS. Why? Because on each cluster, you'll probably have a different DNS record, right? So if we go in apps outside of base, we have here two customized overlays. And if we look on the production overlay, we see here a Helm release patch, which has the host DNS name and also has it configures Flux to pull specific versions from Helm repositories. What I'm telling here to Flux is, hey, I want to deploy the podinfo Helm release. And if someone pushes a new chart version with a stable version, let's say 1001, then automatically upgrade that release inside my cluster. Right? So instead of every time you release a new version, instead of going here in your repo and bumping the version manually, you can give Flux a sample range. You can say, hey, if it's bigger than 100, any new version applied on my cluster. And let's see what Flux did. So if we do Flux get Helm releases and we look at the podinfo namespace, going to see that Flux has detected that the latest version of my app is 503 and has installed it in my cluster. So if I'm doing kubectl -n podinfo get pods, saying that, okay, my app is running right here. So with using a customized overlay, instead of copy pasting that podinfo definition, my app, for all the clusters that I have, I can only specify here the things that are different from one cluster to another. If I'm going to, for example, to staging, in staging, I have other settings here. I have a different host name. And what I'm doing here, what I'm telling Flux, if there is alpha, beta, or any kind of pre-release of my chart, deploy that pre-release in my staging cluster. Why? Because you want to test pre-releases in your staging cluster, and on your production cluster, you only want to deploy stable releases, right? So this is how you can you can create preview environments using Flux. And you can also enable Helm tests and a bunch of things. You can also tell Flux to roll back if the Helm test fails. And there are many, many options what you can do here with Helm releases. What I want to show now is, let's say we want to do a manual rollback. And here I can say the latest version has a bunch of problems, and I want to roll it back to 5.02 from the current one, which is 5.03. So I'm making this change here, and I'm going to commit the change. Now, if I do watch Flux get source is Git, seeing that this is the revision it has pulled, and in a couple of seconds, Flux will detect, hey, there is a new commit inside my Git repo, and it will pull that commit inside the cluster. After it pulls that commit, it will let the Helm controller know through an event, hey, something changed, check out the changes, right? Helm controller detect, hey, I have to deploy a new version, and it will do that. So we can wait 1 minute, or we can use the Flux CLI and say Flux reconcile source git Flux system.
Well, that's reconciling. Another question came from the chat. Ramesh is asking if you can have secret values in the Helm chart.
Yes. How this works, instead of specifying here inline the values, there is a different option called values from, and you can say values from a Kubernetes secret. Now, that secret will be in your Git repo. Of course, it shouldn't be in plain text here. You could encrypt it with Mozilla SOAPs or create a seal secret for it and so on. The idea is a Helm release can take values from secrets, from config maps, or inline values inside the custom resource itself.
So you can encrypt just one of the values?
Yes, only the username and the password. So from the whole values thing, you'll take the username and the password, you'll put that in a secret, encrypt that, and then you'll tell inside the Helm release, you'll say, take this secret and all the other values which are inline, and Helm controller will merge the two in the final values YAML, right? It's like doing Helm upgrade minus values some file, minus values some other file.
Makes a lot of sense.
So what we see here, the old commit is this one, the new commit is this one, my current change. So now if we do Flux get Helm releases, all namespaces, I'm going to see that it has rollback to 5.02. And of course, any kind of change, not this one around versioning, but any kind of change you do in Git, or maybe in other Git repos that are registered on your cluster, Flux detects them and notifies the right controller that's in charge of that particular configuration, right? If I'm doing a change for a Helm release, then Helm controller will act on it. If I'm doing a change in a plain YAML, a namespace or something like that, then customized controller will act on it. And this works not only with changes, but also with deletion. So we have a thing called garbage collection for both controllers. When you delete a manifest from Git, that delete operation will be replicated on your cluster. So if I'm deleting a namespace, customized controller will delete that namespace and everything that's inside that namespace. If I'm deleting a custom resource, let's say a Helm release, the Helm controller will do Helm uninstall automatically for me, and so on. So it's not only about adding things or modifying things, it's also about removing things, right? Any kind of operation is replicated. So,
sorry, go ahead.
Yeah, this was my little demo. I can also show get customizations, where here I have my apps definition, my infrastructure definition, and Flux itself. Now, in an ideal world, if you are doing only microservices, then it doesn't matter on which order you create things on your cluster or you upgrade things, right? That's what Flux version 1 principle is. Everybody should do microservices, should be no problem, no matter the order, it should work. Well, for some companies, that's true. But for most of them, that's not quite true. Like usually you say, hey, I need to have my database deployed and upgraded, migrated the latest version, and only then I can upgrade my app. Or I need to deploy Istio first, make sure that the Istio daemon is up and running before I can deploy my app, because my app has to be injected with the Istio sidecar. If you deploy your app first, then you deploy Istio, let's say on a new cluster, your whole setup will be broken, because even if the apps are there, they are not injected with Envoy. So surprise, nothing will work if you rely on virtual services and so on. So how we solve this problem with Flux version 2? You can define a dependency graph between applications and infrastructure. And how you do that, we go here in clusters, production, and I'm going to look at the apps definition. So this is a customization which is applying this directory. But what I'm saying here is apps depends on infrastructure. What will happen if I'm adding a new cluster to my fleet right now and I'm applying everything inside this repo? What Flux will be doing will not deploy any kind of apps until infrastructure has been applied, is healthy, and only then the applications will be deployed. And this doesn't only work at, let's say, bootstrap time when you create a new cluster. This also works when you update stuff. So if I make a change in this repo, Flux will see, okay, the repo changed, and it will draw the graph of dependencies and will apply the upgrade in that particular order. So it will upgrade first the infrastructure, then the applications. And this is how you can define dependencies and relationship between also between apps or between infrastructure items. This is just an example.
Yeah, I gotta say, we've been using Flux v1 for WebAssemblyHub.io, and we did have some manual parts that you exactly touched on. And I think once we upgrade to Flux version 2, it can be completely hands-off. So yeah, very cool. We have a couple of questions in the chat. This one, I think I even know the answer after seeing it. So Ramesh is asking, in Helm release v1, we used to refer to a Helm chart repo. What is the change in v2? So I think the change in v2, you define a Helm repository source now, right?
Yes. So now in version 2, a Helm release can come from any kind of source. You can put your charts in a bucket and you can say, I want to install this release from this bucket, or it can be in a Git repo, or it can be in a Helm repository. It's up to you how you define it, because let me look at this one. So in here, when you define the source reference, you also specify the kind. So here can be a Git repo or a bucket or anything like that. And you can also share the same Helm repository or the same Git repo between releases. You don't want to pull, let's say, the Binami index file, which is kind of large, for every Helm release you have. You can share that definition between multiple releases.
While we're on the Helm chart, another question came. Is it possible to make canary deployments when it pulls a new version of the chart, of the Helm chart?
Not with Flux, but if you use Flagger and you put a canary custom resource inside your Git repo, it will do that.
So that's a great example on how it's kind of like infrastructure as Lego, right? You can combine pieces together to solve your problem. Very cool. I have one more question. In V1, we have differentiated the Git repo path with Git tags. What are we doing in V2 for that? I'm not sure, Ramesh, what you mean by differentiate with the Git tags. Stefan, maybe it's more clear to you. If you can clarify, Ramesh, that'd be great. Yeah.
Maybe he's talking about image updates.
Oh, that makes sense. Yeah.
So until we have ready the image update feature in Flux version 2, what you can do is for your master branch, main branch, whatever, what is that branch that needs to be deployed rapidly on staging, you can publish a chart with a pre-release minus beta, minus alpha. And then you tell Flux, hey, pull that chart every time. And that's how you can do continuous deployment based on just charts.
Very cool. I don't see any more questions in the chat, so we can summarize. So what I'm seeing in this demo, essentially I can have one Flux in my cluster, and that Flux refer to a Git repo, and in that repo it can refer to a specific path that represent my cluster. And what it allows me to do is essentially represent my entire infrastructure in a single Git repo. And each cluster gets its own Flux that watches the right path in that repo. So that kind of gives me a very powerful way to get all kind of like a single pane of glass, like a one place where all my infrastructure lives. And that's very cool. Oh, let's see, there's a few more questions here. So Ramesh is clarifying, he said it's been used multiple clusters on a single repo. It's been used and be multiple. I'm not sure what you're asking, Ramesh. Are you asking how to do multiple clusters in a single repo? That's kind of what we touched on. You put them in a separate path, and then you tell each Flux that you install on a cluster which path kind of belongs to it, right?
Yeah.
Makes sense.
Yeah, and you can also do you can also drive your production cluster with Git tags. For example, let's say my staging cluster will be synchronizing from the main branch. And instead of using directories, I'll say, hey, my production cluster, instead of synchronizing with the branch, will synchronize with the Git tag. So every time you want to do a release on your production cluster, you can do a GitHub release or Git tag for a Semver, push that to upstream, and tell Flux on the production cluster, hey, instead of looking at a branch, monitor the Git tags. And if it matches the Semver expression, instead of applying the branch, apply the tag itself, right? So as we do with apps, we do Semver releases. You can do the same with your GitOps repository now. That's also something new that Flux version 1 didn't support. Flux version 1 could only follow a branch. Now Flux version 2 can follow a branch, or you can pin Flux version 2 to a specific branch and commit. Maybe you say, hey, during the weekend, I don't want to deploy anything. So you can modify the Git repo definition of your production cluster and say, I want to pin it at this particular commit. This is also something that a lot of people asked from for Flux version 1, we couldn't do it there. But here you can pin Flux to a specific Git tag or Git commit, or tell Flux, hey, follow the latest release of my repo. So all these things are possible.
So Ramesh is clarifying, say we have multiple Flux instances watching a single repo, we can differentiate with Git tags. I think the answer is yes, if I understand correctly.
No. Okay, now I get what he means. So in Flux version 1, how Flux version 1 will know where, what is the last commit if synced? Because it didn't have any kind of state inside the cluster, it will have to push its own Git tag to upstream, and you have to give it the right access to the repo and so on. In Flux version 2, you don't have to do any of that, because Flux version 2 will never create a Git tag on your cluster. It stores the latest commit inside the custom resource, like you saw. That's why you can do Flux get source Git, and it will tell you exactly at what SHA, at what commit it is, because that state now it's stored inside the custom resource definition, right? So you no longer have to deal with all of that, create different, tell Flux, hey, now I'm syncing this one, push the tag with this prefix. All of that is gone. You don't have to deal with it anymore.
Nice.
So we remove that completely. Yeah.
So Ramesh is saying they're going to adopt GitOps. They've done a spike on Flux v1. Would you recommend to continue with v1 or change to v2 or move to v2 for adoption?
So we've announced last month that Flux version 1 is currently in maintenance mode. That means that Flux version 1 will only receive security patches from this moment on. The moment we will have future parity in Flux version 2, so with the image tag update, once that's released, we'll have a 6-month window for Flux version 1. Then we'll archive the repository. So if you are thinking, hey, what's the deadline for me to migrate to Flux version 2? It's at least 8 months from now. So there is no rush, but if you are starting fresh with new clusters, you should definitely be looking into Flux version 2.
Moz is asking, where can I find a technical guide to master Flux in a short time?
It's toolkit.fluxcd.io, the website, and you have there many guides. The Get Started guide shows you how to bootstrap to clusters, like I've shown you. There is also this example repo, but there are many examples there, and we'll be adding more and more use cases while we work on it. This time we want to create example repos. I've created this one for Helm, but we also want to create for plain YAMLs and so on. So no matter how you define your Kubernetes clusters, we want to have an example so you can follow it easily. But for now, toolkit.fluxcd.io is the docs website with all the information there.
Very cool. I think that's all the questions we have. Stefan, thank you very much for joining today. Where can people find you if they want to ask you more questions?
Yeah, on the CNCF Slack, there is a Flux channel there. I'm very active there. Twitter, but I prefer if it's, I don't know, something that's particular to Flux, you have a problem or you have an idea, please open a discussion on GitHub and we'll be answering there. The whole Flux team is watching the GitHub discussions and also Slack.
Oh, one last question. How does Flux handle a Kubernetes operator, for example, the Prometheus operator? Does it deal with it as a normal Helm chart, or is there a special way to handle a Kubernetes operator?
So the idea with Kubernetes operators and Helm is an old thing that's broken, like really broken. Because Helm, especially Helm version 2, you can put your CRDs inside the Helm chart, but they only get applied at install time. So you can use the Helm chart to deploy Prometheus operator, but when Prometheus operator will release a new version, if they change something in their custom resource definition, Helm itself will not apply those updates. It only applies the deployment spec and so on. So what happened, you'll end up with a broken operator because the CRDs are old, but your operator is new. So there are a couple of ways how to solve that. You either tell Flux to pull the raw YAMLs from the Prometheus operator Git repo. They have their YAMLs, or you install the Helm chart with the Helm release. You disable the CRDs install, and you place the CRDs in your own repo, and you keep them synchronized. But I think what we added to Flux version 2 right now is you can add any kind of Git repo and reconcile from that inside your cluster. So if you want to deploy Prometheus operator, Glue, whatever is out there, any open source project has a directory called deploy or config or whatever in their repo where they publish the latest things. So you don't have to rely on Helm charts anymore. You can take that YAML, tell Flux, hey, clone that repo, take those YAML and apply them on the cluster. So that's how I would do it. But of course, you can do it with Helm charts if you want to.
All right. Well, I think that's a wrap for today. Thank you, everybody, for joining. And thank you, everybody. I think that's the stream with the most amount of questions yet. So, Stefan, people really like you.
Nice. Hey.
Yeah. So, thank you, everybody. And we'll see